All right, this video I'm going to look at finding the inverse of a function. And I'm going to give you two examples of that. So we have a function, f of x equals 1/4 x plus 3. And we're going to find the inverse of it. The key word here is when you have an inverse, that immediately tells me y equals x. And in my previous video, I looked at y equals x, and I looked at graphically what does that look like. This can be very important when we're dealing with inverses here. So when you have a function, f of x equals 1/4 x plus 3, that's the same as y equals 1/4 x plus 3. So if I want to find the inverse of this, what I'm going to do is my y's are now x's and my x's are now y's. So what I'm going to do down here is instead of having a y here, I'm now going to have x. So I have x equals 1/4. Instead of an x, I'm now going to have a y. So I'm going to have x equals 1/4 y plus 3. So what I'm doing is I'm switching y and x. So that's the first step, switch x and y. The next step is I want to solve this equation for y, meaning I would like to get y all by itself. So like kind of all my other solving videos, I need to get y by itself, so that means I need to work the order of operations backwards. So I have to either get rid of this 1/4 or that 3. So if I'm going to do that, the first thing I need to do is I need to get rid of this 3. So I'm going to subtract 3, subtract 3. So I get x minus 3 equals 1/4 times y. And then after that, I need to keep moving and trying to solve and get y all by itself. So I got rid of the 3. The next thing I need to get rid of is the 1/4. So this is like dividing by 4. The opposite of dividing by 4 is I'm going to multiply both sides by 4. So when I have 4 times 1/4, you can do that in a calculator. You're just going to get 1, so 1y. And on the other side, I have 4 times x minus 3. Only thing left there to do is I need to simplify this a little bit further. So what I'm going to do is I'm going to take that 4 and distribute it on through. So I get y equals 4x, and 4 times -3 is -12. So I get y equals 4x minus 12, and that would be the inverse. I'm going to do the exact same thing on this next problem here. I'm going to look at f of x equals 3x cubed minus 2. So it starts out as y equals 3x cubed minus 2. Again, the most important thing is y is equal to x. So all my y values are now going to be x's, my x's are going to be y's. So what that looks like is x equals 3y cubed minus 2. So I got to go through the exact same process. I got to get y all by itself. So I got to get rid of this 3, this cubed, and that minus 2. So what I'm going to do is I'm going to work the order of operations backwards. So if I'm going to do that, the order of operations says I got to get rid of addition, subtraction first, then multiplication, division, then exponents, then work inside parentheses. So I'm going to move this 2 first. So I'm going to add 2, add 2. So that's going to give me x plus 2 equals 3y cubed. If I keep going to work on getting rid of everything around this y and get it all by itself, the next thing I get rid of is this 3 out front. That's 3 times y to the 3rd power. So the opposite of multiplying by 3 is divide everything by 3. So over here I get y cubed. On the left side, it doesn't work out that pretty because x divided by 3 isn't anything that's helpful and 2 divided by 3 isn't anything that's helpful. So I'm going to leave it as x plus 2 divided by 3 since it doesn't simplify in anything good. The last step there is I have y to the 3rd power. If I want to get rid of the 3rd power, I'm going to take the 3rd root. So I'm going to take the 3rd root of the right side and the 3rd root of the left side. So on the left side, I have the 3rd root of x plus 2 divided by 3. On the right side, when you take the 3rd root of something to the 3rd power, those are inverse operations, so all you're left with is y. So I have my y all by itself, and I get the cubed root of x plus 2 divided by 3. And that would be finding the inverse of a function in an algebraic way.